So let's start with a hyperbola. It has this form right here. When h is 0, k is 0, a is 1, and b is 1, this equation is x squared minus y squared equals 1. A circle is x squared plus y squared equals 1. When you replace the plus with a minus, you get a hyperbola. You can decide that it opens up right and left instead of up and down, which we'll see in a moment, by doing the following. If you let y is equal to 0, you're going to get x equals plus or minus 1, and that represents these 2 points. They must be on the hyperbola. If you let x equals 0, there is no value of y that makes minus y squared equals 1. So that's why there are no points here telling you that it opens up this way. So as before, h is the x-coordinate of the vertex, k is the y-coordinate of the vertex. For a second, I'll just put those back to 0, 0. Of course, we can change that at any time. And A and B are the stretch in the horizontal and vertical directions. One of the ways to think about this is if you go A to the right of the, not the vertex, the center, and you can show a right boundary, that's the distance of A to the right of the center. And now we're going to go to the left, and that's the left boundary. That's an upper boundary, and that's a lower boundary. Those are B above and B below the center, and now you have the box. This box right here. With an ellipse, it stays inside the box. With hyperbola, it stays outside the box. So when I make B2, 1, 2, stretches the height of this box or rectangle to 2 times 2, or 4. Now B is 3, 1, 2, 3, and so forth. And if I stretch A, make A 2, then the box is 2 this way and 3 that way. Lastly, what we want to know is, where does this branch go approximately? Well, it turns out that this branch approaches another line asymptotically, and that's the diagonal of this box. So to find the diagonal of the box, it's quite simple. You have h comma k, that's a point. Or let me show it first. You have a point that is on this line, that is the center of the hyperbola, h comma k, and the slope is simply b over a. So actually this is the equation of the line right here, and then I can show the other diagonal, which has the same thing except the negative slope. And so now all of this is dynamic. And when I zoom out, what you see is that the hyperbola quickly approaches these asymptotes. Once you get that far, it's easy to look at the other form where y comes first. In this case, the branches open up and down, but it still has the same idea that you go from the center up and down the stretch, vertical stretch, and right and left the horizontal stretch to make this box. Draw the diagonals, find out the 2 points that are on it, and then you can draw it in approaching the diagonals of that center box. And that's it.